Hi and good morning. Here we go. Let's start with 1987 AMC8 question number one. Pretty straightforward question. You can look at the question and tell the answer. It is E 0.426, right? zero point 0.4 plus 0.2 plus 0.006. They have nicely arranged it for us. So it's an easy peasy. Going to the next one. 2 by 25. So we just have to make the base 100. So we have to multiply by 4. So 2 by 25 will be the same as 8 by 100. Okay. So if it's 8 by 100, your answer is going to be 0.08. Option B. Going to the next one. Okay. So you have to add this whole thing and multiply by 2. So obviously you can use, because this is a arithmetic progression, you can use the sum of arithmetic progression formula, but there is an easier method. So if you observe the numbers, right? So 81 and 99 is the same as 83 and 97, right? Which is the same as 85 and 95. This and this. Okay. So what is the sum of one of these numbers? Let's check that. Okay. So 99 plus 81 will make you 180, right? So we have how many 180s here? So you have 1, 2, 3, 4, 5 lines, right? So we say 180 into 5 and the whole thing by 2. So that's going to give you 1800, and that's your answer. Okay, so this is how you do this sum in a really quick manner. Always when you're given sums like this, look at the units digit, okay, and see if you can find a pattern in the units digit which will make your additions easier, adding up to 10. Go to the next question. Fourth one. Martians measure angle in clerds. Wow, that's interesting. There are 500 clerds in a full circle. How many clerds are there in a right angle? Okay, so full circle has 360 degrees. Okay, and we want something now in 90 degrees, right? So 90 degrees is 1 by 4 of 360. So we just have to divide 500 by 4, or 500 into 1 by 4. It's the same. So which is equivalent to 125. That's your answer. Okay, simple one. 125 clerds. Okay, going to the next question. The area of the rectangular region. Oh, simple. You just have to multiply length into breadth. Now, when multiplying decimals, if you have three decimals on the right hand side, in your answer also you should have three decimals, right? So it's basically 22 into 4, which is 88, and we should have three decimals on the right hand side. So this is your answer, 0.088 meter square. Okay. The smallest product one can obtain by multiplying two numbers in the set. Product. Okay, so this time it's the product. So when you want a product to be the smallest, one number obviously has to be negative, right? Because there are negative numbers in the set. So we should multiply with a negative number. And to get the least negative number, we should get the absolute number to be the maximum and then add a negative sign to it, isn't it? So I'm going to take the smallest negative number in the list, and to make this the biggest number without the sign, you forget the sign, you just have to make the number the biggest, right? So I'm going to multiply it with the biggest number available in the list. Okay, biggest positive number available in the list. So this will be minus 21. So that's the least number you can obtain by multiplying two numbers in the list. If you're very confused, just multiply the numbers and check. So 5 into 3 can only become 15, right? And so on and so forth. Go to the next question. The large cube shown is made up of 27 identical sized smaller cubes. For each side of the large cube, the opposite face is shaded the same way. So if this face is like this, the opposite to this is the same, right? The total number of smaller cubes that must have at least one face shaded. Okay, so we just have to find out the smaller cubes where only one face is shaded. Okay, that's your answer. So in this one face is shaded, obviously the opposite shade is white because this is going to be like this. Okay, now same way for this we can count all this because uh, this is the opposite shade, so side is not black for this. Okay, because this is what is going to be replicated here and this is going to be replicated here, so I can count this. Okay, so these are five and opposite I have the same, right? And then this one, the opposite side, all three sides are white, all other sides are white, so I can count this and I can count this as well, right? Because the underneath side is black but here all the sides are white, so I'll put this as 10. Okay, now the opposites have similar faces, right? So it's basically 10 into 2, so your answer is 20. Going to the next one. If A and B are non-zero digits, then the number of digits not necessarily different. So A and B can be the same. That's the meaning. And the sum of the three whole numbers is okay. So you have to add these three numbers. So this plus this plus this. Okay. And how many digits in the sum of this? Okay, is the question. What is the number of digits that can be? That's the question. So now very easily what we will think is, oh, that's going to depend on the values of A and B, right? This number of digits, but not necessarily. I'll tell you why. So what is the least value that A and B can take, they being digits, right? So they can take a value of 0. That is the least value that they can take. And it says it's non-zero, so obviously we can't take 0. So A and B can take the value of 1. That's the max they can do. So if A and B are 1, let's see what is the total of this. Okay, I'm gonna just rub this out. Now I'm going to write the total of this, assuming A and B are 1. Okay, so 9 and 11, 10. Okay, so what is this number? 10019, which is nothing but a 5-digit number. Okay, now what is the maximum value when which A and B can take? Okay, it's 9, right? Single digit number, so it's 9. So now let's make another total with A and B as 9. So this will remain the same. Now this will become 19, so here will be 9 and here will be 1. 8 plus 1, 9 plus 9, 18. 8, 1, 9 plus 1, 10. Is that right? Yeah. So this is going to be your total when A is 9. You done this correctly? Yeah. Yeah. So you see this, we cannot have, this is also a 5-digit number. So whatever the values A and B are going to take, they are going to lie between 1 and 9, right? So your answer can never be any other digits other than 5, right? It will always be a 5-digit number. Therefore, B is your answer. Okay, now going to the next question. When finding the sum 1, 2, 3, 4, 5, 6, 7, sorry, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, least common denominator used. So it's basically an LCM problem of 1, 2, 3, 4, 5, 6 numbers, right? So how do we find the LCM of 6 numbers? We are very used to finding the LCM of 2 numbers and so on and so forth, right? So how about 6 numbers? You just have to keep on, doing for every 2 numbers. So first I'm going to find, so this will be LCMs. So for 2 and 3, right, the LCM, I'm going to use, prime factorization. So I will say 2 into 3, right? So next number I'll find the LCM for is 2 into 3, and here I have 4, right? So 4, 2 into 3 and 4 LCM. So 4 is nothing but 2 squares, right? So this will become, LCM will become 2 square into 3, correct? Because that's the largest value you have here. I've just written 4 as 2 square, that's all. So the next LCM that I'll find is 2 square into 3, comma, this is 5, right? So I have to take 5 here. So here it's very simple. It's 2 square into 3 into 5. This is your next number. So I'm saying 2 square into 3 into 5. That's your number. Comma. This will be 6. Okay. And what is 6? 6 is nothing but 2 into 3, right? So we don't have to take that. So again, this is going to be 2 square into 3 into 5. That's your LCM, right? So this is nothing but, I'm just writing it in prime factors, but it's nothing but 4 into 3 into 5, right? So 15 fours are 60. So that's your number here. So this will be again 2 square into 3 into 5, comma, 7. So this is going to be 2 square into 3 into 5 into 7, which is nothing but 4 into 3 into 5 into 7. That's your answer. 12 into 35, that will 420, right? So this is your answer, 420. Okay, this is how we find the LCM of multiple numbers. Coming to the next question. 4 into 299, 3 into 299, 2 into 299 plus 298. Okay, so this is nothing but, okay, 4 into 299 plus 3 into 299 plus 2 into 299. Okay, now this 298 can be written as 299 minus 1. Okay, and this, what I'm going to do, I'm going to take 299 out of the bracket, outside here. So this is nothing but 4 plus 3 plus 2 into 299 plus 299 minus 1. Okay, so this is 9 into 299 plus 299 minus 1, right? Which is nothing but 10 into 299 minus 1. So this is 2990 minus 1. So your answer is 2989. Just this. Thank you.